For the second example of chapter 12, you will need Node.js in at least version 20 installed. Together with that, you will usually have already npm version 10 or higher installed. If not, you will need to install this as well. Finally, you will also need to have Git available in order to clone the example repository. I did that here already, so I'm already in the subdirectory of chapter 12 native federation. Now, you will need to install dependencies in all of the subdirectories. One easy way to do that is just to run the run.sh script. It will go through all the subdirectories and it will run npm install and then already run npm start in all of them. So let's just do that. And once this is finished, we should have 4 web servers up and running, 2002 to 2003 for the red, blue and green micro frontend, and the composition layer at 1, 2, 3, 4. So going there, you will see our tractor store as we know it, now done by native federation. Like beforehand, we can assert that the dependency sharing works here as well. So I already filtered by React, and you can see we only got React in the standard version 18.3.1 development and React DOM in 18.3.1 development loaded once. All other assets are loaded a couple of times, but importantly, we get the shared dependencies only once, and this is exactly what we wanted. Otherwise, the application is behaving exactly the same as the one with Webpack mode federation, just that we are using here ESMs, so native ECMAScript modules in the browser. They are wired up together via an import map approach, and everything we needed to do was to have a shim that actually makes this whole approach work also in Firefox. If we can, let's say, assure that import maps are just available in all the target browsers that we have in mind, we can also remove this. And then we also bring in the index.ts here, which triggers the setup function that is actually wired up to init federation from the native federation convenience module here. Now init federation will run against the manifest, populate the different microfrontends, and actually establish to have the import map properly set up. Once you have this, you can then import things like React here, and with this define, for instance, a load component on window, which can be quite a nice convenience if you want to lazily load something. So for instance, doing this in our product page, we can just use window load components to get a product recommendations component already in the product page. So when we want to render something, we don't need to come up with a very complicated definition. We just use it as a React component down here, and we are already done, and everything works together as it should. This concludes the example for native federation dependency sharing. For chapter 12, we need to have Node.js installed in at least version 20. What you also will need in order to run it is npm in at least version 10. And you will need to have Git in order to clone the repository. Now, once you clone the repository, you can go into the chapter 12 Webpack mode federation directory and just use the run script to actually, well, go through all the different micro frontends and run install. Afterwards, we'll start up all the different micro apps here and we'll get a running solution working. So let's just do that. Let's run. And after installing all these dependencies, we see 4 servers have been started. We have 2001, 2002, 2003, and the aggregation layer running on 1, 2, 3, 4. This is our tractor store again. It works. It's good. But now it works with module federation, and the interesting part is that we have here an app shell that only makes use of the red micro frontend, but it doesn't really care what dependencies are used by the red micro frontend. The app shell itself doesn't use any dependency, so therefore it also doesn't share anything. But the blue micro frontend, for instance, does already do some sharing. And if you look at the Webpack config, you see there shared React and React DOM/client, who is the singleton being set to true, meaning there should be only one version active at a time. And this makes sense as the blue micro frontend is using these two packages and therefore wants to reshare what it uses itself. Now the other micro frontends do the same, right? So for instance, the green micro frontend also shares React and React DOM client, and the red one is also based on React and uses React and React DOM client. The red one also defines that it uses two more micro frontends, the blue and the green one, and it knows its addresses. So therefore we got this cascade where the application shell knows that there's a red micro frontend, and the red micro frontend knows that there's a blue and a green micro frontend, and blue and green don't need to know anything. Now the application that's rendered looks as it should be, and if we look at the network tab and we do a quick refresh, what we will be able to see is that React itself should only be used once. So here you have the vendors node module React, and we will also have besides React DOM client, but these two only appear once, right, when I group them here. And we got three micro frontends that are loaded, one application shell, basket info, buy button, product page, and product recommendations, but the dependency is only loaded once, right? And this is exactly what we wanted, and this is the dependency sharing that we are looking for.